Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, it is video number 2 in continuation of the topic function, which is the part of the syllabus of O-level Admaths and A-level Mathematics. So in the first video, we have seen the understanding of the following terms, and in this video, we will see the domain and range of the linear and quadratic function and a sketch of these equation, and how does a sketch help us to find the domain and range. So I have taken 3 examples here, and with the help of those examples, I will cover the concept. If you want to see the video 1, I will put the link of that video in the description. So let's see example number 1. This is a quadratic function, and you have to express this in the completing square form, and then you have to find out the range. Now to find out the range, if the quadratic equation is given in the completing square form, it becomes very easy. So before discussing the solution, let's have a little recap of the concept. Now we know that quadratic function graphs are called parabola, and they have either this shape or they have this shape. Now this is called minimum value curve, this is called maximum value curve, and it depends on the value of the coefficient of x square. So the coefficient of x square, if it is positive, the curve is minimum value curve. And if the coefficient of x square is negative, then the curve is maximum value curve. So because it is positive, we know the curve will have this shape. And the numbers at this position, at this place, in the completing square form, help us to find out the turning point. And the meaning, find the range, is basically the values of y on the curve. This is the meaning of it. So let's first of all convert this equation into completing square form. I believe you know how to do it, but in case if you don't, let's discuss it here. Okay, so the best thing is that you'd make the coefficient of x square 1. So I have taken the common factor 2 out. After that, for completing square form, you look at the coefficient of x, which is 6 here. Forget about the sign, it won't make any difference. So you half it and square it. This is the term you add and subtract here to change this part into this part, which is called a perfect square form, right? So, sorry, minus. One term add and one term subtract. I'm considering that you know this is prerequisite, but I'm still revising the concept. So now this is the term 3 square, which I will add and subtract here. So it will become x square minus 6x plus 3 square minus 9 square, minus 3 square plus 11. Now this part, x square minus 6x plus 3 square, will become x minus 3 whole square. I hope you remember the algebraic identity. A minus b whole square is a square minus 2ab plus b square. So I am applying the same concept here. And minus 3 square is equals to 9 plus 11. So the rest of the terms will remain same, and it will become this. So this is how you change your quadratic equation into completing square form. So your turning point is 3 and 4. Now if you look at this curve, I mean, you don't need to, you should visualize it when you change it into completing square form, that all the values of y on this curve are more than 4, because this point has x coordinate 3 and y coordinate 4. So on this curve, as it will go up and up, all the values of y are greater than or equals to 4. So range of the function will be written as greater than or equals to 4, right? Let's see the second example. Now this is the example of linear function. And in this question, the domain is restricted, that you have to answer the question with respect to the following domain. So there are 3 parts in the question. First of all, you have to find out the domain of the function. Now we have seen in the first video, domain means the values of x on the curve. So this is 1 mark question usually. It is just to check the understanding of your concept. You don't have to do any working. So domain of the function is minus 4 to 5. Exactly this is your answer. Then it is saying sketch the graph of the function f. We know from coordinate geometry that linear equation, which is in the form y is equals to mx plus c, if you see this equation, it is exactly the same thing, minus 2x plus 5. So you know that the curve will pass through 5 and it will have this type of shape because gradient is negative, right? So you have to find out the corresponding values for these x. So you will plug in minus 4 here, get the answer, then plug in 5 here and get the answer. So you will get the corresponding values of y for these extreme end of x. So which is 13 and minus 5. So you get from here a point minus 4 comma 13 and from here 5 comma minus 5. And this equation itself is telling you that at y-intercept the curve is passing through 0 comma 5. So once you have these 3 points, you can easily sketch the graph of this function. So if you see here, this is 5. If you want to highlight, no issue. And after sketching this, I would say always label the key points. Like this is minus 4. Draw the dotted line and highlight here the values. Similarly here, highlight the value minus 5. So now on this blue line, what are the values of y? Values of y are in between minus 5 and 13. Because if I ask you, what is the value of y here? You will look at it like this. What is the value of y here? You will look at it like this. Here, like this. What is the value of y here? So you will look at the values of y like this. So values of y are in between minus 5 and 13. So the range of the function is between minus 5 and 13. Now let's see the last example. The last example has 2 parts in the question. This is a quadratic equation and the domain is minus 1 to 9. And you have to sketch the curve and you have to find the range of f. Now, you need to be very careful about it here. You know what? In the case of linear function, to find out the values of y, extreme end, you just plug in the domains, minus 4 and 5 in the equation, and got the corresponding answer, and that was your range. But it doesn't happen all the time in quadratic. In which cases it happens and in which cases it doesn't happen. So let's see here. If I look at this form, completing square form, the turning point is 3 comma 8, right? And x coordinate of the turning point comes somewhere between this domain. Whenever the x coordinate of the turning point is coming in between the domain for which you have to answer the question, do not ever try to get the range just by substituting these values in the function. You will get wrong answer. I'm repeating what I have said. If the x coordinate of the turning point is in between the given domain, because 3 comes between minus 1 and 9 somewhere. So if the x coordinate of the turning point is in between the domain given to you for the function, then do not try to get the range of the function simply by substituting these values. If you will substitute minus 1 here, what will you get? Let's see here. Okay, it's not here, so let's do it. It might be on the next page. Wait. Okay, so when you substitute x equals to minus 1, you get 24. It means your 1 point will be minus 1 comma 24. No need to read this, just focus on what I'm saying. Then when you substitute x9 here, right, this is a common mistake students make. They substitute and they get the corresponding answers, and then they say that the range of the function is 24 to 44. So they straight away write it down like this. But like I said, it will be a wrong answer, particularly when the domain is falling, when the x coordinate of the turning point is in between this. And why it is wrong, I will show you through a sketch now. Okay, so we all know how to sketch it. So I have a turning point and I have the corresponding point. So using these 3 points, I will sketch the curve. Okay, and you know that parabola or the sketch of quadratic function is a symmetrical curve, right? So let's plot these points. Here are they: 3,8, 9,44, -1,24. And again, I would say please highlight the key point. It is not done here, but when you do it in exam, in test, always highlight. It is important. And you can draw these dotted line. Anyway, so now if you see the student who have written this answer for this question, which is wrong actually, why it is wrong? Let's see the values of y on this curve here. The values of y on this curve, if I see this is less than 44, this is less than 44. Sorry, my lines are a little slant, but I do not mean to say this is slant. Actually, I mean to say this is straight. Okay, let me draw it like this. Okay, so if I say what is the value of y here, you will look at it like this. So you see this value of y is less than 24. If I want to see the value of y here, it is less than 24 because 24 is here. So what it proves, that the values of y on the curve gotten by this just substitution will be a wrong answer. So what is the technique? Technique is you have to get the least value from the y coordinate of the turning point, which is 8 in this case. So your range will be on the curve 8 to 44. So this is the technique. Whenever you have the x coordinate of the turning point is in between the given domain, then one of the value will be the y coordinate of the turning point and other will be the value which you get after substitution. 44 or 24, so it is 44 in this case, right? So if you will sketch it roughly, it will be very easy for you. Once students are expert and it is not the requirement to sketch it, they can do it mentally. They pick up y coordinates from here and one of the y coordinates from the point. It depends, the curve has this shape or this shape. Accordingly, they pick up the value. I would recommend you do the rough sketch to avoid any confusion. So thank you very much for watching this video. This question I have just put up here to show you the way it is asked in the past paper. This is taken from O-level Maths, because in ES level mathematics, log function is not part of your syllabus, right? But in O-level Maths, it is log, trigonometry, polynomial, all those, right? So the next video will be on the composite function. If you find this video interested, please share it with your friends. Do press like and subscribe button and share your comments. Thank you very much. Take care. Allah Hafiz.